Maverick is a general user interface for micro-air vehicles, or MAVs. Maverick is a front-end alternative for controlling the MAV, which is currently done through a command line utility. There are 5 basic requirements that Maverick must satisfy. First, it must be able to read incoming data from the MAV, as well as send commands to control the MAV. It must also be able to replay previous missions that the MAV has flown. This small vehicle can be difficult to see, so a grounded camera must move and rotate to always maintain visual contact with the MAV. It must do this all without an internet connection. So how do we accomplish this? Maverick interacts with the MAV through the robot operating system. Let's take a look at how the communication channel works.
Here I'm going to do a short demonstration of the communication between Maverick and ROS. On the left-hand side is our Maverick running, and on the right-hand side is ROS. And currently, the MIT Aztec simulator is running in ROS as well. First, I'm going to demonstrate the communication from Maverick to ROS. First, I'm going to launch our ROS publisher node. Now, the publisher node is running, and it is ready for receiving messages from Maverick. If I click the on button, it will send a message to ROS. If I click again, it will send another message. Next, I'm going to demonstrate the communication from ROS to Maverick. First, I'm going to launch our ROS listener node. Now, the listener node is running, and it is listening to those ROS topics and receiving those messages, printing them to the terminal. At the same time, it also sends those messages to Maverick through socket. Maverick receives those messages and print them to the console as well. This is a two-way communication between Maverick and ROS.
So the communication channel is in place, but writing commands to the MAV is still work in progress. Let's take a look at how Maverick will eventually handle user input for flying the MAV and creating missions. If the user wishes to create a mission or fly their MAV with Maverick, they will plot waypoints on the map. The MAV will fly to each waypoint consecutively until a mission is complete. A waypoint is created by right-clicking on the map. A dialog box will prompt the user to confirm the waypoint. Here, the user may choose to manually enter the GPS coordinate that the MAV will fly to. They may also issue a command to go to the waypoint immediately, land at the waypoint, or hover at the waypoint for a specified duration of time. If the user wishes to remove waypoints, they may do so simply by double-clicking. The red waypoint corresponds with the next point that the MAV will fly to. In this case, it's always the first point.
This is our first flight with the MAV. This is our first time actually receiving live data from the MAV and updating our GUI with that information. On the bottom left, you actually see our interface. We actually recorded this and then embedded this video within the live video that we have shot. You can see the MAV just flying around in a circle in the parking lot. We did this just to make sure we're reading the altitude and the GPS coordinates correctly, as well as updating our yaw, pitch, and roll 3D visualization, as well as our gauges and the 3D map. And you can see the position updating on the bottom left-hand corner, represented by a thin red line. A lot of it's overlapping because, again, it's just going around in circles in a small area. But you can see the gauges updating correctly with the speed and the altitude, as well as the Java 3D window showing the yaw, pitch, and roll. The MAV usually stays pretty steady because, again, it's just hovering and changing its altitude and, again, going in circles. But, yep, this is our first flight receiving live data. An additional camera tab has been added to the application. There are 2 sections within this tab, one for the live camera feed and another one for actually editing some video settings. such as quality, the directory where the file is being saved, things like that. As you can see in the video, I'm just moving around the camera using our servo motors and just get a view of what it can do. Here is actually what a live video would be like, actually shooting the MAV. This is actually a video we shot earlier using just a regular webcam. And here's actually some video feed of our motors moving around without the camera mounted on it. Just so you can see the kind of range of mobility that we have there. And yeah, that's what we have so far for the live video feed.